Welcome to True Projects. In this video, we are going to explain the project Blockchain-based Inventory Management. Introduction. The goal of the project is to create a secure and decentralized inventory management system. Traditional inventory systems rely on a single central computer or server to store all their data. This single server setup is risky because if the server has problems or crashes, the entire inventory system becomes unavailable. Additionally, these systems may not guarantee that the stored data is always accurate and secure. Unauthorized changes to the data can be a concern. To address these challenges, the project focuses on integrating blockchain technology into inventory management system. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. Ethereum's blockchain is used because it can do more than just recording transactions. It can also create and enforce rules through smart contracts. These rules help manage inventory by making sure everything is tracked correctly and fairly. And to handle file storage efficiently, the project integrates the Interplanetary File System, that is IPFS. IPFS provides an efficient and distributed file storage solution. Instead of directly placing the images on the blockchain, which could be inefficient due to the large size of image files, IPFS is used to store the images. Each image is given a unique hash code by IPFS, and these hash codes are recorded on the blockchain. This ensures that the images can be efficiently retrieved from IPFS while still maintaining data integrity and security through the blockchain. Objective of the project. The primary aim is to develop an inventory management system using blockchain technology. Blockchain's features such as immutability and decentralization will be harnessed to guarantee the reliability and continuous accessibility of stored data. The project intends to establish a peer-to-peer network for data storage in block format, each block accompanied by a distinct and secure hash code. This approach enhances security by employing consensus algorithms to validate and safeguard data against unauthorized alterations. To optimize file storage, the integration of IPFS, a distributed file system, will be employed. The project will involve the creation of a smart contract on the Ethereum blockchain to enhance data management efficiency and security. And therefore, by recording equipment details on the blockchain and leveraging IPFS for file storage, the project aims to improve both traceability and security. This entails security, storing equipment-related information for easy traceability and enabling the efficient and dependable retrieval of files associated with equipment. Requirements needed to execute this project are hardware requirements, processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is Register. This module allows new users to sign up for the inventory system. Users provide their registration details such as a username and password to create an account and gain access to the system. The second module is Login. Registered users use this module to securely log into their accounts. By entering their username and password, they can access the system to manage inventory and perform various tasks. The third module is Add New Equipments. In this module, users can input information about newly acquired equipments. They provide details like equipment names, descriptions, quantities, and upload related images to store the equipment's information securely. And the last module is Browse Available Equipments. This module enables users to browse and view the list of equipments available in the system. Users can search the inventory to access detailed information about each equipment listing. Blockchain integration. So, all information about equipments and users' data is stored securely on the blockchain. Blockchain is chosen because it offers data immutability and decentralization, ensuring that stored data cannot be altered and is available across a network of computers. Ethereum plays a vital role in managing inventory data. A smart contract, which is a digital agreement, is established and executed on the Ethereum blockchain. This smart contract streamlines various aspects of inventory data management, ensuring that operations obey to predefined rules and are efficiently executed. Data integrity is maintained in the system through the utilization of the SHA-256 algorithm, that is Secure Hash Algorithm 256-bit. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the data integrity and immutability of the data. So, as I mentioned before, IPFS, that is Interplanetary File System, is used for efficient and distributed file storage. Rather than storing bulky files directly on the blockchain, which could be slow and resource intensive, IPFS is employed. IPFS assigns a unique hash code to each stored file. Importantly, these hash codes are recorded on the blockchain, ensuring that files can be efficiently retrieved while benefiting from the data integrity and security offered by the blockchain. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is Hello ETH folder. In this folder I have a node modules folder. This folder consists of dependencies or modules needed for the project. Now open .bin folder. This folder often contains executable scripts related to the project's dependencies. So here we can see a run blockchain.bat file. Double click on it to start the blockchain. So this script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at the local host and port. This address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. So Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They're deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. So this is the contract address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this. This is images folder in which I have these images which will be used in the application later. This is inventory folder. This folder contains Python code files that are intended to be dynamically loaded into the project during runtime. This is inventory app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. An inventory app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is inventory SQL file. This file consists of Solidity code. It handles data structures, functions and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations and more. This is start IPFS.bat file. This BAT file is used to start IPFS server, which is used to store all product images, as blockchain itself cannot store images. Now double click on it to start IPFS server. So we can see the IPFS server has been started. Now minimize this. Now this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the Django application. So the Django framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework. So here we can see a login and register here links. If we are new users, we have to register first. Click on register here link. Fill in all these details. The username would be Kiran. Give the password. Give the contact number. Give the email ID. Give the address. And after filling in all these details, click on register button. So in blue color text, we can see sign up process completed and record saved in blockchain. So the details have been saved to blockchain. Now click on login. So give the previously mentioned credentials, username and password. The username is Kiran. Give the correct password and click on login button. So we have logged in as Kiran, and here we can see add new equipments, browse available equipments and logout links. Click on add new equipments link. So here users can add new equipment details. The equipment ID would be 2. Give the equipment name. I'm giving it as TV. Equipment type is electronics. We can select from the drop down. Purchase date is 9th of September. Price would be 50,000. Description is smart TV, and we can upload the TV image here. Click on choose file button. So from images folder, I'm selecting this image and click on open. So we have filled in all these details. Now click on add equipment button. So in blue color text, we can see equipment details saved in blockchain, and we got file storage hash code also from IPFS, which will be stored in blockchain. Now click on browse available equipments link. So here users can view all equipments details and can get owner contact number and can view hash code of blockchain for traceability. And we can see a click here link. By clicking on it, we can download files related to equipment. So I'm clicking on click here link here. So we can see the file has been downloaded. Open this. So we can see the file image has been downloaded. Close this, and similarly one user can add equipments to inventory and other users can view and contact owner for purchase. Now click on logout. So the conclusion here is the project effectively harnesses blockchain technology to secure data integrity by permanently recording equipment and user information. Utilizing blockchain's decentralized architecture, data is distributed across multiple nodes, guaranteeing accessibility even in the event of node failures. Blockchain's hash codes and consensus algorithms provide robust protection against tampering, instantly detecting any unauthorized alterations. Seamless integration with IPFS streamlines the storage and retrieval of equipment-related files, significantly improving overall system efficiency. The project synergy of blockchain and IPFS technologies deliver an efficient, dependable, and secure inventory management system. The blockchain-based system can effortlessly scale to accommodate growing user bases and increasing equipment, making it adaptable for diverse inventory management requirements.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.